esto, pero no importa cuántas veces practiques, porque lo que no puedes garantizar seguro es que el tiempo vaya a colaborar, como ha pasado en esta ocasión. Y esto es uno de los desafíos de la ciencia del eclipse. Lamentablemente, el clima de hoy en Pucón no funcionó, pero esperemos que otros que estén en el camino de la totalidad tengan cielos despejados. Y ahora hablemos con Tomás Pusia, de la Pontificia Universidad Católica de Chile. Hola, Tomás. ¿Me oyes?
Hola, ¿cómo están? Sí, muy
Bien.
bien.
¿Cómo
¿Cómo están
estáis
ustedes?
ahí? Nosotros estamos bien. ¿Y vosotros cómo sentís?
Bueno, ya, sí, realmente un desafío, como tú dijiste, que hay que armar muchos equipos, cámaras, pero también garantizar la conexión al Internet con suficientemente banda ancha. Y bueno, armamos todo, estuvimos perfectamente preparados, pero lamentablemente el tiempo no me permitió observaciones de alta resolución con los equipos, telescopios, lentes de bastante poder. Ya, no pudimos apuntar al cielo porque está lloviendo como loco.
Ya.
Pero
Bueno,
de toda manera, pasó la sombra, se cambió completamente el medio ambiente, la temperatura bajó significativamente y bueno, se apagó la luz, se completamente asombró todo. Era básicamente noche por 2 minutos y 9 segundos. Y bueno, ahora estamos de vuelta en un día un poquito ya menos amable.
muy bien. Y tú has estado en otros eclipses, ¿verdad?
Sí, ya, bueno, mi primer eclipse era 99 en Europa. Y bueno, me enamoré en la corona y desde aquí el último eclipse que participé era en 2019 en el norte de Chile, en Valle del Elqui. Y allá tuvimos bueno, cielos perfectamente despejados, tuvimos un montón de imágenes y también grabaciones. Hoy día, bueno, estamos mucho más preparados, con mucho más experimentos y mucho más equipo, pero lamentablemente el tiempo no era ya tan favorable para nosotros.
Bueno, esperemos que a la próxima tengáis más suerte. ¿Cuál será vuestra próxima expedición?
Bueno, ojalá apuntamos al sur de Chile, bueno, mucho más al sur, en el territorio chileno en la Ártica, donde pasará la primera próxima sombra de totalidad por bueno, la península de Antártica y ojalá vamos a llegar con un modo u otro allá y podemos apuntar de nuevo nuestro equipo a esos cielos.
Bueno, pues esperemos que podáis ir allá y que podamos volver a colaborar en un show el año que viene. Y mientras tanto, muchas gracias, Tomás, y mucha suerte.
Gracias, gracias. Muchas gracias a ustedes por participar. Muchas gracias.
Gracias. Pues si acabas de conectarte a nuestro programa, estamos transmitiendo en vivo desde Maryland, en Estados Unidos, cerca del Centro de Vuelo Espacial Goddard de la NASA. Y aunque las nubes taparon nuestra vista, ya pasó el eclipse solar sobre Pucón, Chile, que es donde teníamos un telescopio situado gracias a la Pontificia Universidad Católica de Chile. Este fue un resultado de un momento súper especial en el espacio que solo ocurre una vez cada 18 meses y cuando tienes la Luna, la Tierra y el Sol alineados a la perfección para que la Luna tape la cara del Sol. Y a medida que el Sol se va descubriendo por la Luna en Chile, la totalidad sigue avanzando por Chile y luego por Argentina. Y un dato curioso es que la sombra de la Luna está atravesando el continente a más de 1.600 kilómetros por hora. Como recordatorio, si tú estás en la trayectoria de la totalidad y puedes observarlo bien, porque tienes los cielos despejados, acuerda sobre todo de protegerte bien los ojos. No debes mirar nunca al sol sin la protección adecuada. Y el resto, solo durante la totalidad te podrás quitar las gafas de eclipse o dejar de mirar por el telescopio con filtro de eclipse. El resto del tiempo tienes que estar protegido. Para encontrar las medidas de seguridad, por favor, visita nuestra página web ciencia.nasa.gov/eclipse 2020. Y ahora regresamos con Yari para hablar un poquito más sobre la ciencia de los eclipses y seguir contestando vuestras preguntas. Seguid mandándonoslas o usando el hashtag PreguntaNASA o déjalas aquí en la sección de comentarios. Y no te olvides de compartir tus fotos del eclipse. A ver, ¿tenemos alguna pregunta más? Un segundo. Sí, Bali Muniz pregunta por Instagram. Tengo las lentes del eclipse solar del año anterior. ¿Sirven las mismas para este?
En realidad sí, solamente si no están rayadas o tienen un orificio. Es bien importante que hay que chequearlas bien, que no estén ni rayadas ni tengan un orificio, porque eso es bien peligroso. Si están en perfecta condición, definitivamente se pueden utilizar.
Muy bien, así que comprobad que las gafas estén en buen estado antes de volverlas a usar. Y después tenemos a 000/- nos pregunta por Instagram si los eclipses traen mal tiempo.
Como les comentábamos antes, el eclipse produce la sombra de la luna en la Tierra, pero estos cambios en la atmósfera son bastante pequeños y no logran cambiar el clima de la Tierra en la troposfera, en lo que nosotros sentimos. Hay tradiciones en el folclore, en culturas chilenas, por ejemplo, como la cultura mapuche, que ellos asocian estos cambios que produce el eclipse con cambios en su medio, pero eso es solamente cultura como parte del folclore.
Muy bien, pues te pregunto una pregunta más y luego vamos de vuelta al equipo que tenemos en Chile, porque también podemos hablar con una astrónoma llamada Daniela, pero para daros tiempo del cambio de conexión, hay una pregunta más que nos llega por redes sociales y creo que es perfecta para ti, Yari, es cómo nos afectan las manchas y erupciones solares.
Las manchas solares son cosas que podemos ver entre los telescopios desde la superficie de la Tierra, pero entonces cuando nosotros miramos esa mancha solar en la corona es lo que nosotros le llamamos la región activa, y de ahí es donde se originan mayormente los destellos solares, por ejemplo, o las eyecciones de masa coronal. Estos son eventos, tormentas solares, que pueden causar problemas en los instrumentos de satélite y también pueden causar un ambiente de radiación que puede ser dañino para los astronautas que están en el espacio. No solamente eso, los destellos solares pueden causar problemas en las comunicaciones de radio, en las señales de GPS, porque van a haber cambios en la atmósfera alta de la Tierra. Es algo bien importante porque es un impacto directo a la sociedad, no es un impacto directo como tal a la humanidad, sino a la sociedad porque afecta la tecnología que usamos todos los días.
Muchas gracias, Yari. Y ahora me comentan que estamos listos para ir de nuevo a hablar con nuestros compañeros en el terreno, en Chile, y vamos a estar hablando con Daniela Fernández, que es astrónoma residente del Observatorio Docente de UCE. Hola, Daniela, ¿qué tal? Daniela, ¿me oyes?
¿Sí? ¿Me escuchas?
Hola. Sí. ¿Qué tal? ¿Cómo ha ido hoy el eclipse? ¿Qué piensas? Aparte de lo de
Todo
las
bien.
nubes, claro.
Venimos de hecho justo ingresando de vuelta al estudio. Tenemos una transmisión en vivo, un show con harto material, conversaciones. Salimos a mirar la totalidad, cómo cambiaba ¿cierto? La luminosidad del cielo, independiente de que estábamos totalmente cubiertos por nube y con un poco de lluvia. Fue un eclipse totalmente distinto a lo que estamos acostumbrados a vivir, pero esta es la magia del sur de Chile, muy cambiante, muy particular. Así que todos los que estamos en la región de totalidad de este sector, la mayoría obtuvieron un eclipse con lluvia. Así que algo distinto que comentar, sin duda.
Muy bien. Y Daniela, ¿tú has estado en otros eclipses? ¿Estuviste en el del año pasado, del 2019?
Estuve con el equipo haciendo la transmisión en vivo del año pasado también, con todo el equipo de difusión del Instituto de Astrofísica UC. Y sin duda era muy distinto a este, por muchas características físicas del lugar, del entorno, las características mismas del eclipse, pero este año teníamos preparado, ¿cierto?, un evento mucho más grande, con muchos más instrumentos, pero de todas maneras logramos hacer lo que queríamos, mostrar este cambio de luminosidad, tener nuestro show en vivo y después compartirles también todo este material que estamos haciendo desde acá.
Muy bien, Daniela. Y aparte de eso, aparte de las condiciones meteorológicas, me refiero, también había diferencias en las condiciones del eclipse respecto al año pasado, ¿verdad? La posición del Sol respecto al horizonte. ¿Cómo afecta el eclipse?
Bueno, el año pasado efectivamente el eclipse estaba muy cerca del horizonte, entonces el cambio de luminosidad no iba a ser tan notorio como este año, donde el eclipse se encuentra justo en el cenit, sobre nuestras cabezas, donde el cambio de luminosidad iba a ser completamente cubriendo todo el cielo. Eh, Así que bueno, se apreció, lo transmitimos por las redes sociales, por los canales oficiales del Instituto de Astrofísica UC. Quedamos con las ganas de ver la corona, pero de todas maneras fue algo, una experiencia inolvidable, muy distinta y muy distinta obviamente a lo que fue, por supuesto, el año pasado.
Bueno, Daniela, muchas gracias por hablar con nosotros y de veras os deseamos que tengáis suerte en el próximo eclipse y que podáis ir a la Antártida, que lo veáis bien y que lo compartáis con nosotros. Y ahora vamos a ir de nuevo a responder preguntas de redes sociales y os recordamos que estamos transmitiendo en vivo y en directo con todos los inconvenientes del directo que te tienes que ir adaptando y estamos en Maryland, de Estados Unidos, cerca del Centro de Vuelo Espacial Goddard de la NASA. Voy a mirar si nos han llegado más preguntas de redes. Acordad de enviárnoslas usando la etiqueta Pregunta NASA o déjalas aquí en la sección de comentarios. Gracias. Y ahora voy a mirar un momentito. Sí, Rudolf en Twitter pregunta si se debe tener un escudo térmico delante para no sufrir daño por la intensa radiación del Sol, como hacen las cámaras que le vayan a apuntar a nuestra estrella para hacer su trabajo. ¿Quién quiere contestar esta?
¿Me puedes repetir la pregunta?
Sí, te preguntan si te debes poner un escudo térmico delante para no sufrir daño por la intensa radiación del Sol, como hacen las cámaras que apuntan a la estrella.
No, bueno, eso es una pregunta un poco relativa. Para poder mirar eso, por ejemplo, sí se debe tener la protección adecuada. Si utilizas un telescopio, debe haber un filtro para poder mirar hacia el sol y para poder entonces tú poder enfocar con tus ojos y poder mirar al sol. Si no, te puedes quedar ciego por minutos o de por vida. A cuestión del cuerpo, no, porque uno está dentro de aquí de la Tierra, de la atmósfera, y no necesitas un escudo como tal. Sí, bloqueador solar, ¿verdad? Como siempre, pero no. El problema de los eclipses es que la gente siempre tiende a mirar el eclipse y para hacerlo hay que hacerlo de una manera segura. Y si no tienes las gafas o los filtros de los telescopios, es mejor hacer una proyección y no mirar el sol como tal, sino mirar la proyección que hace la sombra en el suelo.
En términos de los equipos, si pensamos, por ejemplo, en los equipos que nosotros tenemos en la Tierra para los equipos ópticos para observar, esos han sido testeados a muy baja temperatura. Entonces el instrumento mismo está preparado para aguantar bajas temperaturas. Y en términos de radiación, cuando ponemos algo en el espacio, acuérdense que alrededor de la Tierra tenemos la magnetosfera terrestre, que es un escudo protector magnético. Entonces eso le da protección a los instrumentos también. Si el instrumento sale, entonces hay manera de proteger el instrumento o apagarlo temporalmente si supiéramos que la radiación va a ser muy alta.
Igual con los astronautas. Nosotros tenemos astronautas en la estación espacial que está dentro de esa magnetósfera, dentro de ese escudo. Ahora, con las nuevas exploraciones que estamos tratando de hacer para la Luna y para Marte, ya entonces es un poquito diferente porque están saliendo fuera de ese escudo.
Muy bien. Y me comentan que tenemos tiempo de poner algún vídeo más de niños. A ver si nos lo pueden pasar preguntas de Chile y Argentina, de estudiantes allá.
Hola, mi nombre es Sofía Hernández, tengo 13 años y soy de Viña del Mar de Chile. Y bueno, mi pregunta es, ¿qué pasaría si un eclipse dura más de 10 minutos? ¿Eso haría algún cambio en las actitudes de los seres vivos, tanto como humanos o animales? ¿O afectaría al cambio climático? ¡Chao!
¿Quién quiere contestar esta?
Muy, muy buena pregunta. Que dure 10 minutos o más de 10 minutos creo que sería imposible. La Luna se tendría que confundir y quedar pegada frente al Sol. pero sí veríamos cambios muy bruscos en la temperatura. Ya vieron que los astrónomos que estaban en la trayectoria de la totalidad comentaban acerca de cuánto bajó la temperatura y cómo se sintió. Si pasamos 10 minutos, entonces la temperatura hubiera bajado aún más. Y en 10 minutos probablemente los animales estarían extremadamente confundidos, se irían todos a dormir, incluso los niños tal vez se confundirían y se irían a dormir, pero no creo que hubiera un cambio mayor en términos del ciclo del sueño.
Gracias, Bea. Y creo que tenemos un vídeo más.
Hola, mi nombre es Joaquín Gadea, tengo 10 años, soy de Argentina, vivo en Pueblo Andino de la provincia de Santa Fe, curso el 4º grado en la Escuela Abanderado Grandoli, número 980 de Villa de la Ribera. Mi pregunta para ustedes es la siguiente: ¿en qué efectos producen las manchas solares a la Luna y a la Tierra durante el eclipse? Espero que les haya gustado y muchas gracias.
Me encanta la pregunta. Efectos como tal, no diría que hay un efecto directo, pero por ejemplo, si nosotros tenemos un eclipse total solar, ¿verdad? Y entonces podemos ver esa corona solar con los ojos. Y de repente, en esa mancha solar o en la región activa en la corona solar, hay una erupción, una eyección de masa coronal. En ese momento, nosotros podríamos ver esa CME, por sus siglas en inglés, en tiempo ahí real con tus ojos. Y eso sería algo tan impresionante que siempre que tenemos un eclipse total solar, los científicos siempre están ahí como que, mira, por favor, que haya una eyección de masa coronal para poder verla, porque es algo impresionante que uno usualmente ve con misiones en el espacio y instrumentos especializados para eso. Pero en un eclipse total solar seríamos capaces de verlo ahí con nuestros propios ojos.
Y muchas gracias a las dos por contestar esto, y me parece que ya se nos está acabando el tiempo y tenemos una larga lista de gracias que dar. Para empezar, a vosotras dos por vuestro tiempo y vuestras comentarios experto, y también queremos agradecer a la gente que nos ha enviado preguntas por redes sociales, a los estudiantes de Chile y Argentina que nos enviaron sus vídeos, al equipo que compartió su punto de vista del globo meteorológico, que se trataba de Franco Mecconi, astrofotógrafo y realizador audiovisual, y Christian Schmickelow, investigador de la Universidad de Buenos Aires, que está trabajando con AMSAT Argentina y la Sociedad Astronómica Argentina. Y al final, pero no los últimos, queremos dar las gracias a la Pontificia Universidad Católica de Chile por las vistas de su telescopio y por las entrevistas desde el terreno. Esperamos que hayáis disfrutado de este programa y que os gusten los eclipses más todavía ahora que los habéis visto. Como recordatorio, los 3 próximos eclipses solares van a ser en Antártida en el 2021, en el sudeste de Asia y en Australia en el 2023, y en México, Estados Unidos y Canadá en el 2024. Si estás en la trayectoria de la totalidad de este eclipse, anímate a enviar tus fotos, ponlas por redes sociales, etiqueta nuestras cuentas de redes sociales y así nosotros podremos verlas, seleccionar las mejores y compartirlas en nuestras cuentas de redes de la NASA. Para enterarte de futuros programas en español y mucho más, síguenos en las redes sociales en español. Estamos en Twitter, Instagram y YouTube como @NASA_ES, y también estamos en Facebook como NASA-ES. También puedes visitar nuestra página web para más información en profundidad, no solo sobre el eclipse, sino sobre todas las misiones de la NASA en español, y nuestra página web es ciencia.com.
Welcome to our ongoing celebration of 20 continuous years of human presence on board the International Space Station. I'm NASA Public Affairs Specialist Brandy Dean. On November 2nd, 2000, the very first expedition crew arrived at the International Space Station, and since then there have been an unbroken string of 241 astronauts from 19 countries on board supporting science experiments, performing spacewalks, and teaching us how to live long-term in space. But although the crew members in space might be the most visible piece of that puzzle, they are only a tiny percentage of the many, many people who have to work together to make sure missions are safe and successful. We're here today with some of the people that work on the ground, and in particular through our Flight Operations Directorate. And we have a few International Space Station program stowaways here with us as well. I'm going to let each of them introduce themselves and tell a little bit about what they do. And then in honor of the anniversary we're celebrating, I'd love for each of you to also tell us where you were 20 years ago when Expedition 1 was just beginning. And we are going to start first with Norm Knight.
Well, let's see, Brandy. It's really an exciting day, and it's great to be on this panel. A little bit of my background. I've worked in flight ops for many years. I'm currently the Deputy Director of Flight Operations. You know, thinking back 20 years ago, which some days it seems like yesterday, and some days it seems like a long, long time ago, I had been a group lead for one of the shuttle groups that managed the main engines, solid rocket boosters, and external tank, and was recently selected as a flight director. So I was really transitioning from shuttle to station. So exciting times, exciting memories, and look forward to the rest of the panel discussion today.
Definitely. Thank you, Norm. Now we're going to go to Kenny Todd.
Hey, good morning, Brandy, and good morning to the rest of my esteemed colleagues on the panel. It's good to see all of you. I'm the Deputy Program Manager for the International Space Station, have been for a number of years here, but work very closely with the entire flight operations community and have done so for close to the last 20 years now. When I think back to where we were, where I was 20 years ago, obviously I wasn't in this position, but at the time, my focus was over in avionics and software. And one of the biggest challenges for a program such as this one, where you have hardware, literally being built all over the United States and in other parts of the world by different countries, one of the challenges was trying to figure out how to integrate all that hardware and software. And there was a big effort in that time frame back ending the last century when we were really starting to get this program off the ground and in orbit. And so at that time, I had one camp working real-time operations on the avionics and software side, and making sure everything was going okay on orbit as we started to bring up these different systems. And at the same time, I was off trying to figure out the next flights in the queue and how to make sure that we were all going to be good to go, and trying to find problems on the ground so we didn't have to find them and give them to these flight directors later on when they have to deal with them. And again, good to see everybody.
I'm sure they appreciate that early work. Next up is Holly Ridings.
All right, well, good morning, everybody. I'm Holly Ridings. Today, I am the Chief Flight Director in the Flight Operations Directorate, and it is pretty exciting to sit here today, after 20 years and look back, see some of the same faces on this panel and really have an opportunity to celebrate everything that we've done. And so today I'm the Chief Flight Director, but if you go back 20 years, I was just starting out at NASA as a flight controller, just newly minted, and was able to sit console for the very, very beginning of Space Station. And so for a while, I would tell everyone I had the entire history of Space Station in my head, and now it's gotten so complicated I don't think I can remember it all. But for a while I could go flight by flight, and that was how I organized my whole life. Not birthdays, not holidays. Space Station flights were the milestones, and really still are, actually. That's kind of how we mark time in our world. So super exciting to be here, and hope you enjoy what we talk about today.
Thank you. Next, let's go to Emily Nelson.
Good morning, and hey to everybody. So let's see, right now I'm the Deputy Chief Flight Director in the Flight Operations Directorate, and we're still also active flight directors. 20 years ago, I was also starting out as a junior flight controller. The Expedition 1 launch marked a transition where one role that we had early on was going to retire because the space station, which had actually been in orbit for a while, was going to have people on it. And so we were going to retire one position and move into a full team. So I was excited to be transitioning into additional responsibility and getting maybe to become a little bit more senior as a flight controller someday. But I was a pretty baby flight controller back at that point in time.
That's so cool. How about we go to David Korth next?
Hey, good morning. It's good to be back among friends. I hung up my flight director spurs several years ago. So now I'm the deputy manager of the ISS Avionics Software Division, what Kenny was doing 20 years ago. 20 years ago, I was sitting console in what we call the Blue Ficker, a much smaller version of what's behind Emily right now. And I was the lead planner for Expedition 1. And so, I look back and I was reflecting this last couple of days on what we've accomplished since then and thinking, how much preparation went into Expedition 1. And as Emily mentioned, the uncrewed station that existed for a year and a half, 2 years before the Expedition 1 crew showed up, and how much work, effort we all put into working with the Russians, trying to come up with what the plans were going to be, how we're going to integrate things together. And when we finally cut our first plan and uplinked, that's when it hit us. This is real. This is actually happening. And clearly a lot has transpired, both with all of our partners and the vehicle itself and the evolution of operations. So I'm glad to be part of this group today.
It must have been such an exciting time. Finally, we're going to go to Pooja Jasrani.
All right, good morning, everyone. I'm happy to be here with all of you. Like Brandy mentioned, my name is Pooja Jasrani, and I am a flight director. I was selected in 2018, so I'm one of the newer flight directors in our office. I was selected with 5 others, making a class of 6. And so I am one of the baby flight directors, you would say, but have had a lot of experience now at NASA. In 2000, I was in 11th grade. I was in 11th grade and had a lot of space posters in my room, and was very inspired by space and wanted to be where I am today. So very excited to be here. Thank you. I saw a lot of head shaking with the 11th grade, but.
Yes, this is already so much fun. So now we're going to back up a little bit. Although a lot of this group supports flight operations and mission control, that's not everything that flight operations does by a long shot. So Norm, since you're the Deputy Director of Flight Operations, why don't you give us an overview of what Flight Operations Directorate is? Okay,
Brandy, in 11th grade, goodness, that's a shocker. So flight operations, we live in a lot of acronyms. So you hear FOD, it's synonymous with flight operations. It's Flight Operations Directorate. And really what we are is a service organization for all the major programs for development and mission execution. And so what I'll talk a little bit about and give you an overview today is really for station, but it does support all programs. And, the program is our customer. We're an org of about 2,500 people. And we have 3 major functions within flight ops. You could think of us as kind of like a tripod. One leg of that is our astronauts. We have about 47 active astronauts today. The other leg is aircraft operations. We call it AOD. And we have about 60% of the aviation assets for the agency within flight ops. We have 19 T-38s that are used for spaceflight readiness training. We have a cargo transport, the big guppy you've probably seen flying around. We have some high research aircraft used for science and training. And then we have a Gulfstream 3 and a Gulfstream 5, which are used to transport the crews home after landing and get them back reunited with their family. And then we have the plan, train, fly part of the organization, which is really the biggest part of FOD, although it all works together. But really that plan, train, fly is what we do for the program. We really start planning and training each of these ISS increments, which are about 6 months long, about a year and a half out. And the teams work very hard to take the program requirements, metabolize those into a plan, a very detailed plan of how to accomplish this. We train the astronauts, we train the flight controllers, we integrate the teams, and we get ready to go in and execute that in the real-time environment. And that plan really starts from when the astronauts leave their families to go to launch, all through all activities on orbit to the time that they come back to Earth and are reunited again with their families. Where you see a lot of this really culminate is in the Mission Control Center. Many of you have probably seen Mission Control, whether you've seen it in person or in photos. That's the command and control center for the International Space Station. These teams work 24/7, 365 days a year. The flight director is really the conductor in these real-time teams, managing all the systems on board. And the purpose of the teams in there is to manage the systems and also provide crew safety for this orbiting laboratory in real time. The teams typically send about 30,000 remote control commands from the ground to the space station a month to manage this platform. So it's very interactive, it's hands-on, it's tactile, and it's very rewarding. You know, flight operations, we're very rich in tradition. We have our foundations of what we call foundations of mission operations. They're leadership tenets, not unique to FOD, as we say, but really for any effort that requires leadership. It's discipline, confidence, competence, toughness, teamwork, vigilance, and responsibility. And it's these leadership attributes that define our culture. And this culture, in addition to the flight rules and procedures, is really what provides the framework for the critical decisions and the operations that are ongoing, as you see in real time today. The teams are trained to expect the unexpected, to improvise and overcome, and to work with a lot of other team members, both here at JSC and other centers, to always assure astronaut safety, vehicle safety, and achieving the mission objectives that are set forth by the program. And FOD is a little bit unique in that, as a support organization, we can knit this together across major programs with international partners, with cargo vehicles, with crew vehicles, and payloads, integrating them all together in both the development and real-time environment, again, making it all work in support of our customer, the program.
And I think that sets us up now for maybe Kenny Todd to come and tell us. I think it might be confusing to people that the people you see supporting flights, sitting in mission control, and flying the space station don't actually work for the space station program. So maybe you can explain kind of that relationship between FOD and the space station program.
Sure, Brandy. Yeah, you know, the part that everybody sees on TV is mostly astronauts and flight controllers and flight directors. I mean, that is the face of human space flight. Those are the people you see, and quite frankly, those are the people that we, the program, have entrusted with this $100 billion international asset. And so, as Norm said, they you know, they have the responsibility given to them by the program to train our astronauts. You know, make sure that we have a flight control team that's certified and ready to go, and multiple levels deep in failure response. And I think through the course of the history of not just this program, but all programs, you can see that the tenets that Norm laid out today have really been the foundation, which has been used in all human spaceflight programs and been executed very successfully. So anyway, yeah, flight operations is from a programmatic perspective. There are so many different facets of the program. When you look at the engineering, the safety, you know, the people who manage our spacesuits, it's a huge program. But somebody has to have that responsibility to operate the vehicle day in and day out, and we look to the Flight Operations Directorate to do that. Keep the crews trained, keep the vehicle safe, and flying in a good way every day. Now we have a control center over in Huntsville, Alabama, that their primary focus is going to be making sure that while flight ops is taking care of the vehicle and keeping everything safe, that they're working with the principal investigators and getting the science done on board station. So there's a nice nice sharing of roles there. But at the end of the day, we looked at the flight operations director to make sure that we take care of the vehicle, take care of our crews, and again, we complement that with a large workforce of folks that make sure that we hold each other accountable from the standpoint of the technical requirements, our safety requirements, keeping our suits healthy. And so anyway, that's kind of where flight operations sits in our bigger overall program.
Thanks. That was a really good explanation. And I think it brings up that the space station isn't the first program that FOD in some form has supported. You guys have been working with all the human spaceflight programs pretty much since the beginning. But I think probably the space station's first expedition was kind of a turning point for you guys because among other things, it meant that mission control had to be open 24/7, 365 days a year. I think Holly and David, you guys were already flight controllers at that point, so maybe you remember a little bit about what that transition was like.
Yeah, so maybe I'll go first, and then I'll hand to David because I think our perspectives are maybe a little bit different, right? So I came in right when we were building up the team of folks, the flight control team that would work the space station, and so. I didn't start on the shuttle side and then transition over like Norm and Dave's got some experience as well. So to me, the 24/7, 365 is really the only world I've ever known. And we supported from the space station side, round the clock. And then obviously when the shuttle came up and docked and we did joint missions together and really laying the foundation for so many ways that we partner with all of our international partners and then now our commercial partners as well. And so, I was lucky enough to come and be some of the very first people to get certified on the space station side and learned the ropes from that perspective. And, Expedition 1, anytime you do anything for the first time, right, there's always excitement, but also trepidation because you've spent so much time trying to anticipate and consider how it's all going to work together, and then you sort of go live, and then you some of it works and some of it doesn't, and actually that's probably the best part of our job is getting to solve all of those problems, right? That's what all of us love to do after all of the hard work's been put in to prepare. So that's kind of my perspective on it. You're at the starting gate and you hit the go button in station, you hit go and you never stop, it just goes. And so again, after 20 years, that's the only world I've ever known. But I know that Dave and Norm had some more experience on the shuttle side before that than I did, so I'll hand to one of them.
Yeah, thanks, Holly. And I, when I first got hired into NASA, I came in in the space station operations planning area, and we were always 52 months away from launching something, and so. Our management said, hey, it might be good for you guys to get some flight control experience if you're going to be part of the flight control team for space station early on. So I got to spend 4 years doing shuttle flight control and flight planning. And so for me, I got to see, the heritage of NASA, at least when I was young, maybe even as young as 11th grade back when I remember shuttle. And the fact that, I could make a flight plan, and if I wanted to change the flight plan, I took out a pencil, I erased a couple of lines on a piece of paper, I drew some new lines, and then we faxed it up to the shuttle, and voila, there's the plan. And that was the change. And then all of a sudden, this new era of international cooperation and, jointly agreed to operations and coordination, all these different words that were like, certainly we coordinated and we had international partners fly on shuttle. But now, if I wanted to make a change to a plan, I had to go call the Russians. And then after, years later, it was the Russians, the Japanese, the Europeans, the Canadians. We all had to agree on what the plan change was going to be. So cooperation and mutual agreement on how we're going to do things really became important. And so for me, I saw that transition. And the other aspect, and I know Norm's got he saw this same transition in mentality from the U.S. perspective of a lot of experience flying short duration missions. And we were even very proud of ourselves with our 16-day extended duration orbiter missions. And then we go talk to the Russians about this new space station project. And they like, well, we've been flying Salyut, we've been flying Mir, we know long duration space flight. And so we had this ideological sort of conundrum where we both thought we were right. We both thought we had the right approach. And it was really sort of a meeting of the minds where we both had to come together, and we brought in some new technology and some new approaches. They brought in years of experience dealing with long duration crews and how to operate something continuously. And so Expedition 1 was kind of the culmination of all that discussion, and began the adventure that we kept learning, and things have changed quite a bit, and the relationships that we've got with the Russians have changed and evolved quite a bit. And then we brought on all of our partners. So I saw that as kind of one of the main benefits to me of being part of the station, is opening your mind to a different approach and how you can do things, and relying on your heritage and your experience, but using that to build something jointly together.
Yeah, Brandy, I'll add to that a little bit what Dave and Holly said. The fulcrum was really on the shuttle side initially, and so like Dave said, our big long duration missions were 16, 18 days max on the shuttle. And so we had shuttle teams off working shuttle, we had station teams working station, and it was a paradigm shift for a lot of the organization to go from these sprints on shuttle really to this marathon on station. And you could see over time shuttle was king per se, and that's the way things were done. But slowly and surely, evolution of human spaceflight was really transitioning to station and beyond. And so the shuttle, you could see starting to fade. And even though it was bringing up the cargo, that mentality was, hey, this is the new way for the evolution of human spaceflight. And so that mentality of marathon is really, it's exactly what we're doing today. It's what we'll use today for Lunar and Gateway and Mars. And it really, I think, has provided a good proving ground for this. And we have changed significantly from when we started station to now. Our whole flight control team model has changed because, before, if we took that shuttle model, you have a lot of people on console and you're running those folks 24/7. It's not efficient and you burn folks out. And so really what you see today in the station flight control room from a flight op standpoint is what you get. It's a very small, agile team working, again, to make sure that the astronauts are safe and those mission objectives are being met. And we continue to evolve. So it's been fun to watch.
Well, the word marathon is a good one, because the next thing I wanted to talk about was Emily is, I think, the record holder for most time spent in that room in mission control. She has the most shifts for a flight director. So I think would love to hear from her on kind of what a regular day on console is.
Yeah, it's maybe a dubious honor. The flight director I took the honor from told me I shouldn't be too proud of having so many shifts in this room. So when I think of, what a day in the life of space station is like, I think all the way back to when I first started working console for space station was actually in 1999 as a shift duty officer, about a year before the first crew showed up. And so back then, this was an uncrewed ship, and you had fairly junior personnel, obviously, keeping an eye on it in the wee hours. And that was really just, I can remember back then, the whole shift was really just about making sure that we acquired comm every rev, and that the comm was still working, and that nothing looked funny. And then occasionally we'd end up getting a call from our trajectory officers warning us, hey, there's a piece of debris that might be heading towards the station. You should call everybody and get them working that. But, super simple operations. And then over the years, you get through the assembly phase. By the time Shep and company were on board, that was just a little while before the lab showed up. So then we started doing research, and we started really shifting through the years, you know, through assembly, where you're doing a lot of things for the first time, and anytime you do anything for the first time, you're going to learn maybe a lot, and you're putting new systems on board, and you're learning about those systems, and you're building this space station one piece at a time every couple of months until you get to a point where you kind of call it assembly complete. At that point, now for many years, we've been using this amazing platform for research. This is our orbiting research platform. And so a normal day today looks really different from a normal day on any one of those 21 years along the path. We are